Okay, now we'll talk about something called solution set of linear system. What are the solution set of the system? First of all, we will define two kinds of system. Okay, I will use this one. Okay, or here I will write on the side. Just a minute. Yeah. Just moving the pen. And this is the pen, and let's start. For system, we have two kinds of systems. As a system, we have two kinds of systems. First one, this one, called here, this one, homogeneous. Second one called non-homogeneous. Homogeneous, the system will be from this form, homogeneous. System will be AX equal 0. Non-homogeneous, it is AX equal B. In homogeneous, at least we have one solution. In homogeneous, at least we have one solution. So we have one or many. We call this, if you remember, trivial solution. For non-homogeneous, we'll talk about this one later. So, in homogeneous, we have, this is the form of homogeneous. And in homogeneous, we have one solution or many solutions. If we have at least here one solution, this is 0 solution is what we call trivial solution. Okay, now let's talk about non-homogeneous, AX equal B. How we can solve this, how we can solve this. Okay, let's start with this now. Okay, I will show you, for example, determine if the homogeneous has non-trivial. So trivial and non-trivial here, I will explain more for you. This is, I'm talking about now homogeneous. Okay, so it's clear. Homogeneous solution, either one or many. For one called trivial, for many called non-trivial solution. So again, we have one solution, we have many solution. If we have one, we can say it's trivial. If more we or for example, we have trivial, we can say non-trivial solution. Now let's read this question and try to solve this one. Okay, let's actually on this one. Here, a homogeneous equation has non-trivial if and only if the equation had at least one free variable. Yeah. So from this theorem, you can see the homogeneous equation AX equals 0 has non-trivial solution if and only if the equation has at least one free variable. That means it can say it's many solution. Now, let's solve this question. Determine if the following homogeneous. So, okay, we know this from here. 0, homogeneous, has non-trivial solution. Non-trivial solution, that means you have to do, first of all, write, sorry, here it's wrong. Write augmented matrix first. Then solve. Then check if we have free variable. That's mean non-trivial or one variable or one solution. Sorry, one solution. What's wrong with this one? One solution. This can say trivial. So this is the brain mind. First of all, like this question, augmented matrix, solve and check if we have free variable or not. Okay, in this case, we have to solve. So first of all, we have to return back to augmented matrix. See here, this augmented matrix. Then we will solve the augmented matrix as you know. Then let's see here, 0, 0, 0, 0. So again, this is, if you remember, this is x1, this is x2, this is x3. So x3 is a free variable. So it is non-trivial solution. Now, after that, and here's another thing. I want to write the answer in some form. See this here? It is 1. It's the answer for this one, 0. 4 of my. How we get this? How we can get this? We have to solve. Okay. So here I got 3, 5 minus 4, 0, 0, 3, 0, 0, 0, 0, 0, 0. So you can solve. How we can solve? Start from this. Here x3 is a free variable. So let's select 0. Now x2, again, x2 here. 3x2 equal 0. So x2 equal 0. Go up 3. x1, here it's 0. x3, leave at it, minus 4 over 3, x3. So if I want to write the answer, we have a form. This we now see this form, and we can the answer here called here this code. I just one here I will okay. Parametric vector form. What is this? See the answer here. As I want to write answer as a vector. Okay, for vector, if you remember, we have this x equal x1, x2, x3. Close. So here from this one, 3, 5, answer 5 minus 4 equals 0. So if I solve this, I will write like this, 3x1 positive, x2 is 0, so it's 0 positive, minus 4 x3 over 0. Again, here in this solution, leave x3 as it, don't change. Leave as x3. So divide by 3, so it will be x1 positive 0, positive 4 over 3, x3 0. That means x1 here equal 4 minus 4 over 3 x3. It's supposed to be minus. Oh, sorry, this is minus. So here it will be positive. If I want to write, I will write like this one, x1 minus here. Okay, I will write like book here. It doesn't matter. x1 minus, this should be minus 4 over 3 x3 equal 0, like this. And x2 2, and leave x3 without a change. How we can express this one? Okay, see with me, excuse me. x1 here is this, x1 equal 4 over 3 x3. Take this to another part. x2 0 x3 as x3. So I will write like this. See my hand. It is minus 4 over 3 x3. x2 0 x3 right as x3. Don't change. So I will write my answer as a function of x3. So it's equal x3 outside minus 4 over 3, 0, and this is 1. This model called parametric vector form. So I will repeat. Don't worry about this one. Repeat again to focus on the answer. We found this answer, this augmented matrix, and this is the answer. Now, see here, we have x3 is a free variable. So keep as it. Now let's solve for x2. This is x2. x2 here equal 0, so x2 equals 0. Now I will write this one, 3 x1, x2 here is 0, positive 0 minus 4 x3 equals 0, divide by 3x1 minus 4 over 3 x3 equals 0, x1 equal 4 over 3 x3. Now I will write a vector x equal as x1, x2, x3, x1 here as a function of x3, so 4 over 3 x3, x2 here 0, and x3. We can rewrite as x3 outside 4 over 3, 0, 1. Correct? Got it? Or repeat? Got it or repeat? Okay. Now see in our book, see this answer if you can see here. Solve the basic variables x1 and x2 to obtain x3. x2 and x3 is a free variable. As a vector, see, the general solution of x has this function x equal x1, x2, x3. So take x3 outside, it's 4 over 3, 0, 1. This number or this vector, which one? This one can write as a v. So x here equal x3v. Again, homogeneous. Now for solution set. Solution. Now we have homogeneous. For homogeneous, either we have one solution or we have many solutions. For one solution has a name, trivial. For means we have name non-trivial. For which one? This one maybe it's good. For non-trivial, answer will be in this form: x equal x free variable multiply v. For a trivial one, so if we have value for x1, we have value for x2, we have value for x3. This is, we can say its conclusion. So for solution, homogeneous is ax equals 0. I will write here, yes, here ax equals 0. Answer for this one, either one solution. So we have x1, we have x2, we have x3, finish. For many solution, we have, or we can say non-trivial, we can refine the answer as this one, x equal x free variable multiply v, and this is the v after solve the example. Clear or repeat? This now we can say its conclusion for homogeneous. Should I repeat? Is it clear for you? Yeah. Now, how we can understand the question is, okay, good question. How we can see from this is the question. See the second part, good question, sir. Here is 0. This is A, This is x equal 0. This is homogeneous. Got it? Got it? Who asked me? Yeah. All rows are 0 for answer. Yeah. All 0. All 0. Is it clear? So this is, see here, all of these are 0. Any question about this? Got the idea? Should I repeat? Yeah, who asked me? I define, just a minute. Who? Tennis? Hangi tennis? Otherwise, not. Yeah, exactly, Noor. Excuse your name is Noor. So, if we have 0, this is homogeneous. If not, it's not homogeneous or non-homogeneous. Okay? How we can understand the question? If we have a 0 here, that's mean homogeneous. If not, that's mean non-homogeneous. Not or none. Okay, use none, like the book. Okay, we solve it now. Now let's solve this question again. We have 10x1 minus 3x2 minus 2x3 equals this. We have one line. Yes. Answer row. For homogeneous, all these should be 0. Clear? Now, we have like this one, 10x1 minus 3x2 minus 2x3 equals 0. Just we have one line. So again, we cannot solve. We can write this question, or again here, you cannot solve, just we can rearrange. So see this, we can write this one. We have here x2 and x3 as both are free variable. So I will write x1 as a function for x2 and x3, like this. How we can do this? I see here x2 and x3 here are free variable. So we can write this one. x1 takes another part equal minus 3 over 10 x2, oh, that's not positive 2 over 10 x3, and this is a free variable. Here we have two free variables. How we can write like this one? X here, x1, x2, x3. So it is here 0, 3, x2 plus 0, 2, x3, and we have x2, x3. We can isolate x2 alone, x3 alone. So x2 here, 3 minus 0, 3, and 1, and 0. How much to know? Just a question. Again, where is the problem with you? Good question. Returning back to the previous lecture. Just a minute. No, you have to solve. You must solve. But like this one, you cannot solve because just we have one row. The special case. How we can know if it's free variable? See, this is first row for x1, second one for x2, third one for x3. Got the idea? Answer. So here just one row. So this is for x1. Do we have for, let's use A22? No. A33? No. I will repeat again for this example. I know today some students the first time to attend. So this is the question. See, usually answer will be this one for x1, this is for x2, and this is for x3. So if I solve this example, like a previous example here, just a minute. Okay, answer after solving like this. See, this is A11 for x1, A22 for x2, A33 for x3. So let's answer for a question how I can know. This is x3, x2, and this is x1. Got or repeat? who asked me, how can I know? So if I return back to this question, just we have x1, we don't have x2, just we have a11, we don't have a22, we don't have a33. So this is x3 here is a free variable, x2 here is free variable. Got it? Got it? One line, so just x1. Yeah, I told you this is a special case here. So x1 here, just for x1, we don't have x2, we don't have x3. It's a little bit strange equation. So yeah, thank you so much. So for this reason, x2 and x3 both are a free variable. And see here, we will write x1 as a function, x as a function for x2 and for x3. So 0, 3, and this is here 0, 3, x2, 1, and x3 here it is 0, 2, x3, and here 1, and we will write this 0. So we can write a function. Yeah, this is a special case for one single line equation. We have answer for x1, but we don't have answer for x2 and x3. So we write x1 as a function for x2 and x3. Got? Got? Jamal, got it, sir? Okay. Now, we will say about this one, see this x equal x3 is a name, parametric vector form. So this kind of writing, for example, x equal x free variable dot v is like this. This is called, name is parametric vector form. Why is this? Because later you will find in the question, write the answer in the parametric vector form. So this is the parametric vector form. Again, parametric vector form just for free variable. Doctor, I solved it. I found x1, x2, x3. So we don't have free variable. x1 is, x2 is, x3 is, that is. Parametric vector for free variable. If we don't have free variable, for example, I have x1, I have x2, and x3, that's okay, finish. Like in our like what we studied at high school. We have x1, for example, 2, 3, minus 1, minus 2, so it's okay. If I have answer, I have answer. If I have free variable, non-trivial solution, so I must write answer as a parametric vector form if he asks me this one. Clear or repeat? Okay, now let's start. For this one, for which one? This is the answer. This is the answer. This is the answer. This is the answer. Okay, got this is the answer. This is V. This is V1. This is V2. Or Y U1, U2. Or UV. Excuse me. For a new student who just attended the first day, excuse me, return back to the previous lecture and see it. No. This is who asked me, Ayla. This is V1 and this is V2. So here in this example, as I told you, strange example. We'll solve many examples later. So wait me. This is V1 and this is V2. Clear? Should I repeat or go ahead? Okay, thanks so much. We have example. We will solve. Just with me. Now, another example or for non-homogeneous linear system. In this case, see this one. It is in case ax equal b. B is a number. Let's be. So let's try to solve this example. I have a, and here the for here non-homogeneous ax equal b. This ax equal b. We cannot say trivial or non-trivial. Let's start to solve and write the answer in parametric vector form. How we can do this? Okay, keep this here and let's go ahead. He asked me solve. Describe all solutions. Okay. Answer this and start to solve. We will solve this one like I told you before. And we will find the answer. If I solve, after solving, here we have solving, solving, that means augmented matrix. We will find that means x3, see this, x3, x2, x1. So x3, 0 equals 0. That means x3 is a free variable. Now x2 equal to, x2 equal to. Now x1 minus 4 over 3 equal minus 1. So I will write x1 as, see this one, minus 1. Take this, another part with positive 4 over 3 x3. Now let's rewrite again as a parametric vector form. So x equal x1, x2, x3. Yeah, excuse with me. x1 from this one is minus 1 positive 4 over 3 x3. x2 is 2 and x3 is 3. So in non-linear homogeneous or non-homogeneous linear system, I have here, see, this is, I have here minus as a number, 2 as a number. So separate again. I will write like this one, minus 1, 2, 0, positive x3, here 4 over 3. Here we don't have, here we have 1. So see this one, answer for parametric vector form is x equal, this is, we can see b positive tv, not television, t here is this a vector and this is t the free variable. So we have here extra part. If I compare this one with the previous one, in the previous one we don't have b, just we have free variable. Okay, go up for this one. See here, we don't have. Yeah, just some solution. See here, we don't have, just we have x2, for example, this example. X is x1, x2, and x3, and this is the answer. X as an answer is this. So I have free variable and I have vector. But we don't have any numbers after that. So we can write x equal t, v, or x, yeah, this t is a free variable. And this is the v. Now, in non-homogeneous, after solving, see, x equal this part. X equal p, a number, plus x3 and v. So, with me, excuse me, step by step. Non-homogeneous is the original one. I can convert non-homogeneous to be homogeneous when I have here ax equal p. If p equals 0, that means non-homogeneous will be homogeneous. So the original case is non-homogeneous, the general case. If I make b equals 0, That means non-homogeneous will be homogeneous. Got it? Got it? Now I have ax equal b. If I make b equal 0, that means ax will be, repeat, okay, sure, I will repeat. Okay, see here, repeat, clear this, clear this. Now I have non-homogeneous, non-homogeneous. Anyway, it is the general form for equal b. For the question is ax equal b. Now, if I can make b equal 0, that's mean ax equal, so wait. Ax equal 0 here. And this is homogeneous. Got it? Who asked me? So I can convert none to be homo if just make b equal 0. That is. So general case is this one. Which this one is ax equal b is general case, and I can convert general case to b special case, homogeneous special case when if I can make b equal 0. So if anyone asks you, is this homogeneous or non-homogeneous, go to the second part. If the second part is 0, that means homogeneous. If not, that means non-homogeneous. And from homogeneous, if you comparison again, I will write here again conclusion. Okay, here, okay, open this one. You can copy, not this here. Now let's together talk about today lecture is equation for linear algebra. We have two kinds of equations for system. First one, homogeneous. Second one is non-homogeneous. Homogeneous is ax equal 0. Here ax equal p. Okay. Now for solving, this is the form. Now solving for this one. For this one, we have two things, either trivial or non-trivial. Trivial, that's mean I have x1 equal number, x2 equal number, x3 equal number, or we can say one solution. For non-trivial, we have free, use another pen, for example, this one. We have free variable. So I will write answer x equal as TV. T here is a free variable. V is a vector. Now, for this one, we cannot say we have trivial or non-trivial. We have to solve. So we have answer in this one. X equal P plus TV. P is a numbers. T is free variable. P is a vector with this one. Clear this? Clear this? Got the idea? And as you see from this one, if I make P equal 0, this P will be now this one. This is summarization for the course. It's easy, got it? This form, by the way, called parametric vector form. This one called, which one? Green one, this one. Parametric vector 4 answer. Yeah. Should we solve one example about this and read the question inside your book? Yeah, sure. We start with this example. Okay. Now, writing a solution set of constant system in parametric vector form. By the way, constant system, that's mean if we have solution. Constant, that's mean if we have solution, either one or many. Don't forget this one. Constant, that's we have solution. Inconstant, that's mean we don't have solution. This is the first picture. So repeat, constant, that's mean I have solution, either one or many. Inconstant, that's mean we don't have. Suppose the equation AXB is a constant, that mean we have solution. Then the solution set of X equal B is like this one, W equal B and VH for this one. Here how we can use this one or solve this one, row reduced augmented matrix, express each basic variable in terms of any free variable, write the typical solution, and decompress X2 in linear equation of each vectors. Now, determine if the system is non-trivial. Non-trivial, that's we have free variable. First of all, homo or non-homo? Hurry up. No homo or non-homo? Yeah, all. I need all. This system, homo or non-homo? Just what? All. Hurry up. Thank you so much. This is homo. How can I know? Go here. Where is the pin? Oh, the pin is gone. This one. See here? Yeah. 0. So this is homogeneous. Now let's solve. We'll solve. So here we have 0, 0. Okay, my eyes is for this one. So x3 is a free variable. That means the system is non-trivial. Yeah, system. Thank you so much. Now I will write here. I have x2. I have x2 here. Huh? I have x1. So x2 equals 0 minus 12 x2 equals 0. X2 equals 0. Now this one, 2x1 minus here 0. Okay, my 5x2 positive 8x3 equals 0. Here 0, that means we cancel this. Okay, take another one. So x1 equal minus 8 over 2 x3. This is equal minus 4x3. Then you can write the answer as parametric vector 4. But see this question here. Okay. Determine if the solution has a trivial solution. Did he ask me write parametric vector 4? No. So just in this example, I want to show him or the answer. That means I have x free variable. That's mean non-trivial solution. Did he ask me write parametric vector 4? No. So don't do this. If he asked to, if not, not. Another question, same thing. Try it. If the system has non-trivial solution, that's mean free variable. See here, I have value for x1. I have value for x1. I have value for x2. I have value for x3. So it is trivial solution. Do we have any free variable? No. x3 is 0. x2 we can say it's 0. And x1 here is 0. So the system is trivial solution. Constant, after that trivial solution. Got it? Repeat. Okay. Others. Follow the method example and see here to write the solution of the given. He told me homogeneous in the parametric vector form. So here I have to write. Solve, then write. Solve, then write. Solve, then write. Okay, we're going to solve. Okay, we have free variable. See this? Here it's 0. So x3 is a free variable. See here, answer. Exactly. Thank you so much. Non-trivial solution. So it's minus x3 equals 0. Here 0 and 0 equals 0. That means x3 is a free variable. So I will write my answer in parametric vector form. See the answer here. X is x1, x2, x3, 5x3 minus 2x3, and this is x3. Take x3 outside, and this is 5 minus 2, 1. You can see it is p equal t v. This is t, and this is v. And this is the general answer for this one. Again, this is non-trivial solution. Got the answer? Got the answer? Any question about this? Yeah, go ahead. Now, describe all solution in part 4. He told me this is equivalent one. This is but directly, this is matrix of A. Wait. Here we have a lot of problem. A x equal, he told me for parametric vector x equal 0. And he told me where this is A. So x1, x2, we have x3, we have x4. So I have here two free variables. What are they? X3 and x4. Doctor, this is augmented matrix. No, this is, he told me here it is A. So we have to add 0, 0 to solve. So this is not augmented matrix, this is A. And this one, AX equals 0. So this is A. So you have to write augmented matrix, and this is x1, x2, and we have x3, x4 as a free variable. So you have to write the answer as a function of x3 and x4. See here, for example, x1 and x2. Then here we have x1, x2, 3, 4, and you have to write the answer as a function of x2 and x3 and x4. Got it? Any question for this? I guess now it will be easy. Yeah, all. Is it easy or hard? Can I repeat? Should I repeat? Should I repeat? Okay. Now, another example. Describe all solution for is he gives over to me A. This is he told me this is A. So this is A you have again to solve, and here we have x3 and x4, same thing for the previous example. Now, oh wow, what is this? Describe all solution again for ax equals 0 in parametric vector form. This is A. Again, this is A. So this is C. x1, x2, x3, x4, and we don't have x5. So how we can solve it? In example, we don't have like something like this, just explanation. So here we have x5, so x5 and x1 and x1, x3 and x5 are remaining variable. So we can say here x3, x6 is free variable, and x2 also 0, so it's also free variable. x2 is a free variable, so free variable. Okay, this is an example you can cancel because a little bit complicated, so you can ignore an example. Okay, what is this? What did they don't know. Now, suppose a solution. So in this example, he gives to me solution. A certain system of linear equation can be described as x and x. So here we start from down to up. I have solution. He asked me, okay, with x free value, use vector to describe this system. I want to describe the answer, describe the system. What is this name of the system? Okay, wait. Here we have, this is x1, x3. So x3 is a free variable. And here also x3 is a free variable. Okay, minus 2, 5. That means answer will be in this form. X equal B plus TV. B is this, you can write in this one, so x1, x2, x3, 5 minus 2, and you can write in this form. So this form called non-homogeneous system. So from the answer you can guess what is the name of this system. If it is B equal TV, or a free variable with vector, so we can say this is homogeneous. If it's equal B plus X, a free variable with V, for example, here we can say it's non-homogeneous. So I can predict which system starting from output, from the answer, based on parametric vector form. Got it? Any question about this? Any question about this? Okay, I will repeat. Thank you so much. See here the answer. Okay, I will. See here, sirs, this is the answer. He gives me, suppose the solution. So we start from down to up, from solution. Okay, this. Then we'll start from solution to the system. Here we have the solution. Solution in this one, it is x equal C1, 5 plus 4x3. And we have, for this is, okay, I will rewrite again. Here, x equal x1, x2, x3. x1 from here is this, 5 plus 4 x3, x2 it's this minus 2, x3, and x3 here is a free variable. He told me x3 is free variable. Isolate like this, 5 minus 2, 0, positive 4 x3 minus 7 x3, x3, and this is p plus x3v. This is, if we return back, we have 2, 4 for answer. Okay, this one. For answer, we have either x equal TV, so this is homogeneous, or we have x equal P plus TV, so this is non-homogeneous. So what is the answer? This answer in this form. So what is the name of our system? It is non-homogeneous. I don't know the system. Yes, you don't know the system. You know the answer. From the answer, you can guess the system. It's homo or non-homogeneous system. Got it? From the answer, you can guess or you can know what is the name of the system. Who asked me, Dilara? You asked me about this one. Who asked me? Delay? Yeah. Got it? Wait just a minute, we have. Shared screen is black or clear for you? Shared screen. Do you have problem with screen? Can you see my screen? So I go, it's its own problem. You can see the registration after if there is a problem with this one about the screen. Okay, I will stop then share again. Just maybe you can solve. Okay, now. Who told me? Can you see the screen again now? Khalil. Khalil, you told me that, yeah, Khalil. Muhammad Khalil, can you see the screen? You told me I have a problem. Yeah, I know, but I have a problem with Khalil. He told me I have a problem. So I want to check Khalil. Thank you so much, everyone who answered me. Now, same thing, support the solution. And here also they told me which is the system of this one. Now, it's a good question. Describe the solution of the following he gives to me the system in the parametric vector form. Now, let's start with this question. This is homo or non-homo. Yeah, together. Homo or non-homo system. Homo or non-homo. Hurry up. Hurry up. Sleepy. It's 12. Yeah, thank you so much. It's non-homogeneous system because it's ax equal p. So this is b. Now let's solve. Now, this is your job now. Do we have free variable? It's your problem, Khalil. Do you have free variable? Yeah, what's the free variable? What's the name of this free variable? Together. It's x1, x2. Yeah, thank you. x3. X3 here. Free variable. So I will write x1 and x2 as a function of x3. So take this one, x3 here, 0. See this? Now x2 minus 3x3 equal 3. x1 was to 4x3 equal minus 5. Then you have to solve. After solving, we have to write the answer as a vector x. Just a minute. In non-homogeneous, we cannot say trivial or non-trivial. Just this is for homogeneous. Sir, thank you so much. Trivial and non-trivial just for homogeneous. For non-homogeneous, we cannot say this one. Black one? Oh, why this one? Non-trivial and this is music, the soul. And trivial, this for homogeneous only. Okay, take care about this one. Just for homogeneous. We cannot say non-trivial, just for homo only. For non-homogeneous, we cannot say this one. Now, after solving, you can find here x1 and x2 and x3, and you can find answer in this form. P plus this is T multiply V. Is it clear for you, sirs? Any question about this? Until now, this course is easy for you. Okay. Now, let's go to our book and try to solve some examples from our book. Here's our book. This is our book. It's in chapter number 1 in our book. Based on this is here 1.5 solution set, and it's return back to read the questions from your book. Here, determine if the system has, okay, close this one. Yeah. Determine question number 1 if the system has non-trivial solution. So see, again, I told you, this is just for homogeneous. See, this is all is homogeneous. So trivial and non-trivial just for homogeneous. So here you have to check if you have free variable or not. I solved one. Follow the method and write solution set in parametric vector form. I solve one of this. You have to solve, and if you have free variable, you have to write in parametric vector form. Another question, this one, he gives to me A. So this is A. So you have to check which one is parametric vector form and write as it. This question 13, I solved it to you in the notes. And he let me describe the set if it's homo or non-homogeneous and write the answer for this one. Again here for this question, which question? Up, I guess. Yeah, this one. Down. For the method, describe the solution of the following system parametric vector form. If the give, I don't need geometric description. I need just to explain. And we solve one example for this one. Okay. Here we have true or false. Yeah, with me. A homogeneous equation is always constant. True or false? What do you think? False. No. Correct. Constant, that means we have solution. So homogeneous usually has solution, either zero or number. So it's correct. It's constant. Inconstant, that means there is no solution. Got? So first one is correct. What do you think? It's chair idea. Who said no? What's your opinion about this? Aina, true. Yeah, thank you so much. You are correct. Mustafa, oh yes. Jamal, thank you so much. Yeah, usually for homogeneous we have solution either zero. We have zero. So that means solution. Yeah. The homogeneous has trivial solution if and if the equation has at least one free variable. Correct or not? See. Read C carefully together. This. The homogeneous equation has trivial. Thank you. It's non-trivial. Non-trivial. Not trivial. Take care about this tricky. Thank you so much. D. The equation x equal bt plus tv describe linear x through v parametric to p. Correct or not? Align through v to p. Okay. Try to find answer for these questions, for example, at your book, and some of them can come to you as true or false in exam. Next week we'll continue and we'll go to something I didn't give in previous week, but I will give. For example, here code about linear independency, and we will go to about some application linear model in business science and engineering in your book. So next week we'll continue. I hope inshallah in this chapter we will try to finish 1.7 independence and linear model of business science and engineering. I tried to solve some examples for you how we can use linear algebra kind of what we study mathematically in physical issues. Any question about our lecture? It's easy or hard?